And for some of us asking yesterday's session, the recording stopped and I didn't pay attention. So I will do a recording for that and send. So let's go there. So this is a simple one, right? Valid. Let me zoom out my screen. Valid palindrome. A face is a palindrome if after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. Alphanumeric character includes letters and numbers. So giving a string S, return true if it's a palindrome, or false otherwise. So take a look at this input. Yeah, let me do what I do from time to time. And here. So we're pasting it here. So simply, it says, of course, converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters. You read the same forward and backward. So you see A, the last is A, removing all alphanumeric character. An alphanumeric character includes letters and numbers. So you are also removing every space between. So this is a space. So you are going to skip this and check for M, then after M, A, you know, and ignore the comma, ignore the space, A, ignore the space, P, ignore space, ignore this, L, A, you know, A, N, ignore the comma, ignore, you know, the space. Then of course A, and then we have C inside. So C is like a middle number, so you can tell, okay, this is alphanumeric. Now let's see if there are any constraints. So of course there's a constraint here that empty strings should be considered palindromes, and they give us the length of the number that's 1 is less than or equal to length. So the string you are going to give is from, the size of the string will be from 1 to 2 times 105, and S consists of printable ASCII characters. Now, basically, how do we solve this? How do we partake in solving this? Well, you know, in this case, you are not going to have a double loop per se. Or how can you test if each character, you know, they are in a sense a palindrome? How can you check for the first and last and check, you know, till you get to the middle? So first of all, we aren't going to loop through this more than once, you know, and then since I'm using the language Java, you can't access the index of a string in Java. So say something like, I believe JavaScript should be otherwise. Say if you have S, or let's say print out, the string is not like an array, system.out.print line S0. So let's run this and see what we got. So array required but string found. So we are not dealing with it like an array. We can't really access the index of a string per se. So a string is a kind of a stranger data type. So we are not really concerned about this string. Now, another thing to consider is how do we change this thing to an array so that we can easily loop through each element, that's each item in the string. So basically, in JavaScript, I believe you should be able to do this, right? But this is Java and it's not giving that option. So I'm going to build with Java on this. So how do we do this? There's something called char array in Java. So a char array is like an array of characters. Now, char array is an array of characters. So let's hold that aside. But then there are some caveats in solving this, right? Let's go to this. Some of the caveats is number one. Let me say some caveats. Number one is, how can we check if a certain char is removing all non-alphanumeric. So it's non-alphanumeric. If a char is non-alphanumeric. Alphanumeric character includes letters and numbers. So if you have number 1 is an alphanumeric character, a letter from A to Z is an alphanumeric character. That's one of the caveats we want to check there. Then the other caveat we want to check, of course, is how can we check if a number, if it is in the same case. That's if it's lower or uppercase, right? Because in Java, char A is not equal to A. So we are going to look at this because this is part of number 2 here. So these are the two constraints we want to specifically constraint, right? But we want to look at how we are going to handle for these two things. And of course, I would have added the number 3rd one, which is this 3rd one is Java specific, right? Is how can we look through a string like an array, But this is Java specific, and I believe JavaScript you could be able to get the string like an object and look through each index of it. I might be wrong in that part, but I could look at it differently, but I'm thinking this is Java specific. How are we going to convert this is a string? Because we can't get string dot I, because access char, let's say access char in a string by index Java. So we have this getting a char. All right, there's such a method chart, and you can get charts, right? And then let's see, get character as a string. Finally, okay, this is something else, right? Getting a character by index for a string. Okay, this is getting a character. All right, so there's a method called chart. I didn't particularly think of this. In my mind, I was thinking of converting from string to character array, but let me see the time complexity. Chart time complexity Java. But for string also often, so they are asking, this is Stack Overflow. So we have, the chart method is so often, so basically it's so often, chart is so often, it's a constant for string buffer. All right, so we can use chart without converting from what do I call it? From string to char array. Now somebody is saying, why are we looking at some documentation online to be able to solve what we are solving? Now there are different kinds of interviews, right? And then I think for a developer, some of the things they won't expect you to, if you're interviewing for Google, any of the company, right? They are not going to expect you to run it in code. They are going to expect you to give them a pseudo. You are going to write it such as in Google Docs, right? But then there are other companies that will allow you to do this, but some of them are going to allow you to check for resources online, maybe monitor what you're checking. But then in my case, I would have converted it to a string array first, but then now we have chart, which is O of 1. which is a constant time operation, which is O of 1. So we can do that. But then the next caveat we are going to look at, okay, we've handled this. How can we check if a certain char is non-alphanumeric? How can we check if it is non-alphanumeric? Then how can we check if it's in the same case? So going back here, I could have s dot to lowercase, I believe, in Java, to convert everything to lowercase. And of course, this operation will run in O of n. I mean, there's nothing you can do about this O of n, right? But then let's take a look at the other thing. So we can convert everything to O of n and deal with it as though it is all lowercase. We are converting everything to lowercase to test for it, right? Because we can have a caps here and a lowercase here and a caps here because proper nouns and everything. Then how can we check? How can we check if a certain character is non-alphanumeric? How do we check? What is the best way to check? Because this is now like a sub problem inside the problem. And then anyone that gives this kind of assignment, this is how I will handle it, right? They are each character has its ASCII code. I might not be able to cram the ASCII code because they are just way much. If you check for the ASCII code in Java, let's see. Yeah, there's an ASCII table map. So all right, so we can have from 0 to 9, and then we have from 65 to 90. But then everything in between is looking like, oh, we have 58, 59. We want to check if the character is not in this, right? This is ASCII code in Java. So there's also a different ASCII code for lowercase numbers, which will now be different. Now, I'm going to keep this table open and I will show you how I will handle it in this table because I want to check if it's a number. I will check if it's the ASCII code is within this range, right? From 48 to 59. Then if I want to check if it is a letter, since we are converting everything to lowercase, we are going to ignore all the uppercase here, and we are going to check from 97 to 122, right? If we are interviewing for Google for this, we are going to expect that we are going to delegate this to a different method, right? If you are interviewing for all those companies, if you are going to any code interview, but most times for some of these companies, they give you this thing in. They just send you a link and you have to handle it in the link. So in that case, like I said, they should be able to give you something to research with, because I don't think any developer knows this thing off by heart. It's too much of a stress to be able to look at this thing. You could delegate some of these things. We are just dealing with how we're using data structure and solving that. 27 minutes. So let me start with this. So how do we convert from, basically how to check the decimal value of ASCII character? Java, basically something like this, to find ASCII value of a character. So I believe you convert it to int first, something of that nature. Yeah, you convert it to int and then check the value. So that's basically it. So back to our solution. So we have converted S to lower, right? And in this case, I want to create another memory because I can't update the value of S here in Java. So let me say string, maybe let me say string v equals to S to lower. This is an O of n operation. Then we want to say, let me just do it this way. I'll do it. Int lower numeric ASCII presentation is equals to, now what do we have here? As a table, 48, 59, right? Or I could just use this as constant. So let me just do 48, 59. Let me remove this, comment this out, because I don't want that. I want to do 48 to 59, then lowercase letters we are going to have within the range of 97 to 122. So 97 to 122. So we just need to keep this in our mind now. So how are we going to look through it? Now, this will now introduce us to a different way where we handle data structure and algorithm, because we have already handled all the caveats here. Let me go to this place. We have already handled how we are going to check if it's alphanumeric. We are going to convert it to an integer and check if it's within those two ranges. If it's not within, we ignore that character. Then we are out to check if it's the same case. We say we are going to convert everything to the same case, so lower case, so A will be lower. Then of course we did this. So now let's go into the main implementation of solving the problem, right? What we are going to do, there's a algorithm pattern we use to solve our data structures and algorithm, which is like a two-pointer and looping through. So we are going to have 2 pointers. One will start from the leftmost and the other one will start from the rightmost, and we compare looping till we get to the center character, right? So we are going to say int left pointer, because of, I don't want to be writing, left pointer look like a big word. Int right is equals to, in this case, g dot length. G dot length. Then we are now going to loop. So we are going to be taking from left to right and be decreasing as the case may be. So we are going to say while left is less than right. So we are going to loop. So if we get to a point where maybe we get to a point where left is equals to right, in this case is C, we stop the loop. This has the center element. Imagine for this, let's say we start from R, check R is equals to A is equals to C, C is equals to E. Now this is not a palindrome, E, then we check for A. At that point, left and right, they are just 1 digit different. So we can't check for the middle element. But for this one, we know it has one center middle element. So we are just going to, because it reads the same way from back to front, right? So it has the center element is odd, right? But this one is even. But let's go into solving it. We don't want to check if left is equals to right, because when left is equals to right, we are going to have the same digit. So there's no point. When left is equals to right, we have reached the midpoint of, the array. But now I want to do g length minus 1, because since we are starting from 0, we are going to end at length minus 1. So I will say, in left most, equals to g dot char at left. Same thing with int right most equals to g dot char at right. Basically what these do, I've explained this loop and I'm explaining this, we are getting the character at that point. And of course, from the documentation, char at produces O of 1 for strings. So same thing here. So we are having O of 1 operations here. So we are not particularly concerned that we are going to have O of n, because char returns the character that index. So we are now going to do this, right? If starting from left, now we want to check if it is either a number or a digit, right? So we are going to say if int if int, okay, so instead of making this more confusing, right, putting int into the brackets, because if the left and the right is the same thing, we are going to have them they will have the same char representation code. So I will just have the int here. Yeah, this should be better. So converting it to ASCII, the decimal value immediately, so we don't have to bother about much, right? So then we are going to say if leftmost, right? If leftmost, is greater than 48, and leftmost is less than 90. Okay, we have to use greater than 49. Okay, no, greater than 48. So we have to use greater than or equal to, greater than or equal to 48, and leftmost is less than or equal to 59. If this, now I'm going to make this loop. Okay, to make this thing more readable, let me delegate this to a function so that it makes the code more readable. This is getting difficult to test. So let's have a different function. Let's call it public, public is alpha numeric int value. So we want to check if it's alphanumeric. So we are moving this delegate inside here. So we come here, we do this. So that we leave the parent function less noisy and confusing. So let me take out this parenthesis first. So if it's this, then we know that is a numeric character, is either from 0 to 1. Or if this is this, return true, then, if same thing here. Sorry, instead of using leftmost value, because that's what we're passing inside this. If value, we want to test too for the 97 and 112. So we have 97 and 122. Return true, return false. So if either of these is true, it will return true, else it will return false. Now I can compile these two functions together and put a bracket here and put if this or this. But then I'm just putting it this way to make it more readable and more understandable, right? So if none of this is true, it will return false. But if anyone is true, if it tests for this one is true, it's going to return true. If it tests for this one is true, it's going to return true, else return false. So now we are going to test if is alpha numeric, if it's alphanumeric, leftmost, right? If leftmost is alphanumeric, then we are going to also check if rightmost is alphanumeric. Because if anyone is not alphanumeric, we have to, we have to ignore that character. So we want to check if rightmost is alphanumeric. If they are both alphanumeric, then we are also going to check if leftmost is equal to rightmost. Don't do anything. But let's say if it is not equal, then return false. And what does this mean? We are going to check if the leftmost character is alphanumeric. If it's true, then check if the rightmost character is alphanumeric. If that is true, then we are going to check if leftmost equals to rightmost. At this case, if it is not equal, we know that we are not dealing with a palindrome, then we return false. Right? So we are going to return false if we are not dealing with a palindrome. So we are breaking it here and say don't go further. I hope it's clear. Can anyone hear me? Let me see.
It's clear. It's clear.
Okay, all right. Thank you so
Yes,
much.
we can hear you,
Yes.
sir. We can hear you.
All right, thank you. So that's what I did here. But what will happen if any of them is not alphanumeric? So we are going to start with rightmost. So we have an else statement here. If rightmost is not alphanumeric, say for instance, we are dealing with this, what do we want to do? We want to decrement rightmost by 1 so that it will come to L instead. So we are going to have right minus, right? So we are decrementing our rightmost if it's not alphanumeric. So we are going to do the same for leftmost, right? But now what will happen if leftmost is non-alphanumeric? We are supposed to increment it. So we are going to come here. If leftmost is not alphanumeric, we are going to have our else left plus. And this should run fine. But what will happen in the case where both of them, are alphanumeric? Now that's where, because this is where, I mean, for me, the first time I was having issues, because if we are going to increment or decrement, if we are going to increment or decrement, we want to check the while loop again. But assuming, right, all of this is true, we are not going to decrement this or increment this. We are going to have it outside the code. And then, yeah, we have to have right minus left plus. We should be able to, we should be able to have this. We should be able to have this in our code. And why is this happening? Yeah, we should be able to have this in our code. But now the challenge is, what if one rightmost minus? We are still going to get left plus, which will not work. So in this case, if we have a caveat, we want to be able to continue the loop. Now, I should hope by now everybody understand what continue is, right? There's something like continue, break, and pause. Continue means do not execute the remaining parts and just continue the loop. Break means do not execute the remaining parts and, leave the loop totally. Forget about whatever the loop if left is not equal to right. But continue means, okay, we are done here with this current value in the loop and continue. So with this, we can be able to return if it is false or if it is true. Now we have this because our function has to return something. So because we are expecting return of false, someone is chatting me up. So let me do this. Activity monitor. Sorry. Yeah, that is better. The notification was getting a bit distracting. So we continue and do this, but our code has to return something, right? So we want it to return a default value, which is true. That is assuming everything runs through and the code, it finds out that everything is correct, it returns true. Because here we are already returning false if we find out leftmost is not equals to rightmost. So at this time, I should be able to run the code and see what happens and see how to debug it, right? Let's see. Okay, public is numeric, and this should return a Boolean, right? So let's run that. All right. I'm used to coding in Kotlin, so some of these things. G.length cannot find symbol G.length, so we want to deal with that as a function. Finger crossed. Oh, come on. Leftmost. Small letter. So small letter. So finger crossed. Let's see what happens here. So wrong answer. It returns false. Now, where is our code missing it? Now, I would assume at this point, I don't even know what is being returned. Now I have to debug the code, right? This is how it should work, but now I should be able to debug it and debug it within time period. But I mean, if I'm coding on paper, this is basically the concept. So let me see how it returns false, because the output is returning false when it should return true, and we are checking if leftmost is not equals to rightmost, return false, right? So now let's go into it, and leftmost is character left, rightmost is character right. If alphanumeric leftmost, so let's just print it out and see. So I want to system dot out dot print line leftmost cross right. Let me just print this out and see where the error is coming from. 97, 97, 32, 109. So it's coming from, so let me not even do that. Let me do this so that I will know at what point the code is breaking. So AA space M, so increment AANN, comma A. A is equal to A, PP, LL, L, this. So it's stopping at this, which should be a big issue. So we have AA, we have space M, test is not true. We have MM, we have AA, we have N, and then we have AA, then we have PP, then we have, PP, yeah, then we have L with space, then it's testing with this. So I think we are having an issue with this. It's taking this as an alphanumeric code, which it shouldn't. So now I will just have to go to my ASCII table again. Pardon me about that. ASCII table. So we have 58 here, 58 instead of 57. So we have 48 to 57. So back to the code. What did you do here? 48 to 59. So we are having it wrong here. So let's say 48 to 57. Now let's run this. Now what I did here, I just debugged. So it's an accepted answer, right? Because I was debugging. Why? Because for my error, I knew that the error was coming that is reading this as an ASCII because my function here isn't correct. So now this is the accepted answer, right? Let me remove my printout statement and run this again. Now I don't know how poorly or how better my code will perform. So let me just submit it. Can you see it? Can you all see my screen? Hello?
Yes, can see your screen.
Okay.
Yes, we can.
So this is performing 5 milliseconds. Yeah, this is the first time I'm running it, so you can see there's no submission here, and I took the risk. I was like, hope this code doesn't come and embarrass me. But then, yeah, faster than 80.66% of this memory usage, this less than 78%. Can I reduce this memory more? If I could assign this to itself, but I think that's that might not be the solution. But then at this point, you are not really going to think about much optimization because this code is running in O of n times. It's practically an easy problem. So we have this running in O of n. So we know this is running in O of n. Forget these comments we have here. They are not running in anything. Left, right, getting the length of a string is O of one operation, O of 1. Chart of 1. Let's get all the places that use time complexity if statements. Now we also spoke about function. This function is doing nothing of any loop at all. So everything here, the function itself is running in O of 1, like almost constant time, maybe O of 1 to at most 3. So let's say O of 3. Let's just give it to that. So in this case, we are having O of 3. We have that in this case. And then in this case, we have O of 1. Then in this case, we have O of 1. Then in this case, same thing, O of 1, O of 1, O of 1. So O of 1, 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 O of 1. But this function itself is running in. Who can tell me, I mean, the time complexity of this loop? Now it's not O of 1, so it might be O of 1. I just wrote that here because I need to edit it. Maybe I don't need to edit it, but can somebody rightly, guess what is the time complexity of this loop?
O of n.
O of n, great, yeah, O of n. Actually, it's actually O of n over 2, but we spoke about removing constants, so we are going to have O of n, right? O of n. So basically, this is the solution we can get. You are not thinking of optimizing further. So going through the code bit by bit again, I explained we want to convert everything to lowercase because the ASCII value of caps lock of A is different from the ASCII value of lowercase of A. So that's why we did this. So it's an O of n operation. I mean, could I, be able to, let me see if there's a way to convert something to lowercase, right? So let's see, convert char to lowercase Java. Oh, there's a lowercase class, but then let's see how this will affect the running of our code. So instead of pardon?
I said yes, there is what's it called, character dot to uppercase and lowercase.
Let me see. This is how we are going to use it, right? This is how we're going to use it. So using let's see if our code even runs correctly, because we are changing from G. Yeah, let's see our time and space complexity. Oh, it was not slower. I mean, this is adding some complexity to it. I mean, we are now taking out the O of n operation. Now we are doing character to lowercase, and then it's still producing 6 milliseconds. And why is that? But actually, it's even using more. Or maybe it's lead code playing tricks on us. So I will just submit again. But I mean, at this case, you are not trying to optimize any further. Oh yeah, this time is 4 milliseconds. So this is kind of a faster solution. This should be a faster solution. But like I said, don't really trust the inbuilt functions of your native programming language, because it might just be wrong. It might using O of n, you think it's using O of 1. But basically, this is how we solve this, either this way or the previous way, right? But this way should use less memory. That's why I'm wondering why this. I mean, if I remove the comment, I should be able to expect faster run. And then, and basically, you understand. But let me run through it again. I was running through that. We initialize the left pointer at the extreme left, then we initialize the right pointer at the extreme right. So we don't want to convert to an array. So we say int leftmost, convert it to lowercase, rightmost, convert it to lowercase, then convert it to an int. Why are we converting it to an int? So that we get the decimal value of that ASCII code, because every code has an integer representation. So we convert it to an int so that it's easier. Then we call its alphanumeric function here. And I think this is just to keep the code clean and delegating of function. I mean, if God willing, we would get into maybe code reviews and better ways to write code later, right? This function now is basically testable because it has only one responsibility. We are checking its palindrome. We don't care to know if it's alphanumeric or not. So there's another function called if alphanumeric. So if you can test this with unit tests, we can use integration test here and but basically much that's off the topic of discourse. But then keeping the code clean, it's alphanumeric, right? Leftmost, rightmost, leftmost, rightmost. So we check if leftmost is alphanumeric. If leftmost is alphanumeric, then we can proceed. If it's not alphanumeric, what we want to do, we want to shift it. In this case, we want to shift it a step further. We want to shift only the left. Yeah. Sorry, let me see where this curly braces end, right? So this is what we are doing. We want to shift only the left. Then we check if leftmost is alphanumeric, fine. Then we check for rightmost. If rightmost, at this point, the character at the rightmost index we have now. If the rightmost is alphanumeric, then we test if they are equal. If they are not equal, right, we are going to say, oh, false, because if both of them are alphanumeric and they are not equal, then there is no reason for it to be true anymore, right? It should be false. If we are going to edit our test input and we are changing this M in Panama to P, let's say we save that and we run it, we are supposed to get a false right now because it is false, right? Yeah, so output false, false. So you see, because this is not a palindrome again. So at that point, P is alphanumeric, M is also alphanumeric since it has skipped A. So it's going to test, is P is equals to M? No. Then it's going to return false and the code will break. But like we are testing time complexity, we are looking at the worst case scenario. Worst case scenario. There's a way I could make this thing more complex, but I mean, returning at this point, you are telling it that, hey, this is not palindrome. There's no need to look through it again. So that's what happens here. Then same thing, we reduce the right index if we find out that whatever is at the rightmost, whatever is at the right index is not alphanumeric. We want to reduce it. And then I explain what continue is here, right? There are three ways to leave a loop. We have break, we have continue, and I think we have pause. I don't use pause much of the time, but I know break is, if we have break here, we are going out of this loop in total. It's just like what we are doing here. Return false means no matter what it is, don't continue the loop. Continue means, all right, we are done with whatever we want to do at this stage. Don't execute whatever is beneath the loop and continue. Pause, yeah, I don't know what that is. Maybe I'll look at the documentation. So just assume we now remove, of course, we are returning true if we never found false. So it's just the default return function in this thing. So just imagine if we didn't have continue just here, right? Let's see how our code will run. Yeah, we are expecting an output of false, false. Let's now submit the code and see what will happen, because we are testing with only one input here. So here we are testing with multiple test cases. So it's saying, hey, wrong answer. Then if you check details, for this case, false, true. Oh, we are not even testing with the right input at this point. I mean, that should be Panama. So it's going to be false. That's if we do not use the continue here. So same thing if we do not use the continue here. So I mean, basically this is how I will run the function. So looking at the overall time complexity of the function, let me take this to let me take this, take everything. Let me take this to docs. So we have O of n here. All these documents are none. O of n plus 1, that's n plus 1. This is also running in O of n, so it is going to be O of, n plus 1. I should be writing that down somewhere, right? Let me just go to LeetCode, yeah. So that we could have this written down somewhere. So we have O of n plus 1 plus, of course, n divided by 2, n divided by 2 plus 1, 1, 3, 3, 1. So let me just add all these things, because 1 plus 1, 2, 6 plus 2, 8, 9, 10, 11, 12, 13, 14, 15, 16, So we have 16. But then we have this, yeah, we have 16, so that should be it, then 1 here. So maybe O of this thing plus 17. Then according to the rules of, whatever we had, I said I will submit that, I didn't submit it. So n plus 1, this will translate to n of n, right? We didn't school that time, carry like variables somewhere, and divide by 2 plus 1 plus 17, which will be this 18, which will now be this, because n over 2, like I said, looking at the worst case scenario, n over 2 become n. Then, of course, that will now become 2n, which of course, at the end of the day, will now become, let's drop this because this is about a constant. The size doesn't change if our inputs change. This is what we are looking at. So we are going to get up to n. Of course, ignore this because this is also a constant coefficient, right? We are more concerned about n times n and so on. But we have O of 2n, which is almost translating to O of n. So our execution of this function is O of n. So with this being said, we have handled this standard. Now, this is a simple one, right? Quite simple, yeah. Quite simple, but it touched two-pointer exception. Let me see. There's something leads code. Let me just go through this. I think I opened it somewhere. Okay, I didn't. It's called area of water. Container with most. Okay, no, trapping rainwater. This is the one I want us to check. Trapping rainwater. So we are most going to get to this. This is hard, right? I mean, I will send the link of this to the group too, so anybody can try attempting it. It is not easy, but it's using the two-pointer exception. So we are going to start from left to right. But then starting from left to right, we are going to perform some operations before we get to our final answer. But from what we've done so far, is there any questions? Any questions? Is it perfectly understood? Anyone want to say something? I mean, you can talk, you can unmute yourself, so I don't have to go to the meets. Any questions?
Yes. Good
Okay.
evening.
Good evening.
Sorry, I joined a bit late.
Oh,
If I get what was going on,
can you guys hear? I think your line is breaking. Maybe it's from my network.
Yeah, the
missed it.
network is breaking, so I don't think I can hear anymore.
Okay. Yes, I can hear you now.
okay, can you hear me now? Okay, I wanted to confirm first that from what we're doing, we're trying to solve a
Palindrome,
conundrum.
to check if a string is a palindrome or not.
Okay, but we are doing it for strings
Yes.
here.
Yes.
So I wanted to ask, does Java do regular expressions? Because I think when you were trying to remove the non-alphanumeric characters, I think regular expressions does that.
Yeah, I mean, what you said is very, very fantastic. So let's see how regular expression works. Regular expression, time, complexity. Java. I mean, I understand that, right? What's the time? You say the time complexity of a regular expression is often. You get right. It might make our solution more complex.
Sorry.
Yeah. Someone is saying something.
Hello?
Yeah, you were saying something.
Okay. Yes. I mean, so if we are to use this regular expression, that would make our solution to be O of n square, right?
No, 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 no. Of course, it will still be O of n because this is where we are going to put our regular expression somewhere here and see what regular expression is. Oh, yeah, it's going to go to O of n square. Maybe, maybe not. But wait, if we are going to use regular expression here, we are going to filter the string, filter it and take out every non-alphanumeric character. So we are going to get O of n here in filtering the regular expression. Of n in filtering the regular expression. But guess what we are going to have to? We are going to have, because regular expression algorithm, you are going to define what you want out of your regular expression. So you are going to have, maybe you are using Java inbuilt method, so it's cool, right? But majorly what we do in regular expression, we are going to have a variable that we hold all the things we want to filter it out. True of us?
True most times.
Yeah, true most times. So this is going to take an extra space complexity. Now, you get the point. This is going to take extra space. Storing of variable is going to take extra space.
That's true.
That solution might be faster than this solution, but some of the pros and Google, they spoke when I was in one of their meetings at Quora. They said, there's a point of optimization you get. You shouldn't be optimizing further. What are you looking for? Regular expression could be best in this case. It could be easier. I'm just saying this is how I would solve it, right? But maybe I could have tried with regular expressions. And for some reasons, I'm not just particularly that interested in regular expressions because languages change and then your code is now dependent on. Now, I'm an Android developer, right? I build with Kotlin multi-platform. So when there's Java has even done us so much in that regard, same with Google. When there's a little change in the language way of doing things, your code might break in a big time. Some of the things might become deprecated. They might use some data structures that are deprecated. And so once you are building your own solution, and most of the companies, once they are building their own solutions, they don't outsource some of those functions to inbuilt method, right? They build it themselves. But it's still a great choice. I've used regular expression in one of my C# projects I was building for desktop because it was not part of the project. And I trusted the regular expression. I was trying to build some of the database I'm going to use in the project and impute in the project. So it was not part of the project. It's not what I'm shipping to the clients. I'm just building it to be able to, you have this project, you found out that you need to build this thing for this project. Instead of outsourcing it because of the complexity in time, I'm using time complexity, because of how much time and how much funding and finances it will take and explaining it out. I had to pull, I was pulling information from sites not with API now, just pulling and reading and picking out some of the information I want to use, right? So at that point, I used regular expression, but I'm not going to be visiting that code over and over again because it is not part of the solution I'm building. It's just what I built to be included in the solution. So regular expression is very, very fantastic. I loved it. I still do. But at the time, I've stopped sharing my screen. So at the time, it becomes imperative for you to own your own code. This is you. This is your solution. This is what you're building. This is what you can test. Regular expression is already tested, right? That's why I said in anytime you are building, try as much as possible to avoid using those native code. That cool?
Yeah.
All right. Thank you. So any other questions? Today we are a bit faster because we are solving an easy question.
Yeah, I have a question.
Yes, please ask.
Apart from this tutorial, do you have any other resources like a book or a PDF or a recommended resources for to learn DSA in depth?